Anyway, so do PE before you multiply the negative 6. Okay, let's look at part J. It says f of 1 or f 1. Well, I don't see no f. Ugh. But we can use the same little theory that we just used. We're going to take this 1 and we're going to plug it into whatever the f was. Well, the f, or the f compose f, was, we did it up here. It was 4x plus 3. And now I'm going to take that x and replace it with a 1. And I get 7. Yay. Okay, so the only thing from this paper we haven't done is the g of f of x. Oh, gatos. And that's because this problem was bigger, so it's going to take longer. I left it until the end. Okay, so I just rewrote my f of x and my g of x. And now I'm going to do g parentheses f parentheses a. Okay, well, let's see what that means. It says I'm going to plug my f into my g equation. Oh my gosh. So I'm going to take this f guy, and he's going to replace these little x's of my g. What? Okay, so my g equation was negative 3x squared plus 2x minus 6. But we just said I'm going to take the f and replace all the x's. So I'm now going to have negative 3 times something squared plus 2 times something minus 6. And I'm going to take the f and put it in these parentheses. So it's kind of like I'm taking the f and plugging it into the g. When we draw these backwards arrows, it's kind of like composition instead of multiplying. So I'm going to take this 2x plus 1 and put it where this x is from the x squared. I'm going to take this 2x plus 1 and plug it in where the x is from the 2x. I sneezed. Okay, so now we're going to distributize. And this right-hand stuff is easy. We just get plus 4x plus 2 minus 6. But this stuff over here on the left is kind of cranky. This is where, oh, I didn't write it on here. But if we have something squared, we have to do it times itself. So let me whip out this 2x plus 1 squared real quick. That's it times itself. And I'm going to FOIL it, or you can just regular multiply. And when I FOIL it, 2x multiplied 2x is 4x squared. Outsides, 2x multiplied 1 is 2x. Insides, 1 multiplied 2x is 2x. Last, 1 multiplied 1 is 1. And then I add up, and I think I can add up this oi. It makes 4x when I add them up. So now I'm going to get 4x squared plus the oi of 4x plus 1. Woo! So we just did the 2x plus 1 squared. But I still have to do the negative 3. Multiply that. And then let me go ahead and bring down what we already distributed. Like, we already did this 2 times 2x plus 1. It was this purple stuff. So let me just bring it down real quick. Plus 4x plus 2 minus 6. Okay. And then now I'm going to have to distributize this negative 3 times everything in the parentheses. And we get negative 3 multiply 4. Negative 12x squared. Negative 3 multiply 4. Negative 12x. Negative 3 multiply 1. Minus 3. And then bring down all this other junk. Plus 4x plus 2 minus 6. Okay, now we're going to combine like terms. I don't see any other squareds except for the square I'm looking at. So let me write it down, minus 12x squared, okay? Then for my x's, I got a negative 12x plus a 4x makes a minus 8x. Then for my naked numbers or my constants, I got a negative 3 minus 6 is minus 9. And hey, baby, stop there. So this one was redonkulous because of that squared. We had to do it times itself. And then there was something in front of the squared. So after I did it times itself, I had to multiply it with a negative 3. Then I combine like terms. Okay, the last thing we're going to do is domain. And here it is. In the tricks, it says domain of an equation. So first, there's only 4 cases. You either have a fraction with x in the bottom, x inside a square root, a fraction with a house in the bottom and, oh, that's what I just said, or everything else. And everything else, the answer is always negative infinity to positive infinity. So let's see here. If I want to find the domain of this, 3x plus 1, well, 3x plus 1 is not a fraction with x in the bottom. It's not a square root. It's not a fraction with a square root. It's everything else. So the domain is negative infinity to positive infinity. Woohoo! These are my favorite. Okay, let's look at part B. Is it in a fraction? Nah. Is it in a house? Nah. Is it in a fraction house? Nah. So the domain is negative infinity to positive infinity. If we wanted to, we could like graph this beast. And if I graphed it, I think it would look like this. And then we could just label the arrows and the bottomest point and find domain like we did in 2.1 by looking at a picture. Okay, let's look at part C. Is it a fraction with x in the bottom? Heck yes. Okay, so let's look. When there's a fraction with x in the bottom, like a 10 commandment of math is that thou shalt not divide by 0. That's not Jesus. That's like a math guy from back in the day. Okay, anyway, so we cannot divide by 0 because if we divide by 0, it's like this dinosaur. The whole world ends. I mean, not the world ends. He dies. So we can't divide by 0 because, you know, we die. So instead, we're going to take the bottom and equal it to 0. Well, let's do that. We're going to take the bottom, which is 5x minus 1, and equal it to 0. Then it says we're going to sad map if we just have a good old x. And we do. So let's sad map. You add the 1, and you get 5x equals 1. You divide by 5, and you get x equals 1/5. Okay, well, this is what x cannot be. So everything else from this negative infinity to positive infinity is good to go, except for the number 1/5. So to write that, there's a trick. You just say negative infinity to the 1/5 and 1/5 to the infinity. And we use a parentheses around that 1/5 because we cannot have that number in the domain because the dinosaurs die. So, if you believe in dinosaurs. So our domain is negative infinity to the number 1/5 and then 1/5 to positive infinity. So whatever number makes your denominator 0, like for us it was 1/5. When we write our domain, we write negative infinity to that number. And we use parentheses because this 1/5, if we plug it into the bottom, it gives us a 0 on the bottom and the dinosaurs die. Okay, let's look at part D. We got a house. Okay, well, let's look at what this not Jesus guy says. It's like Pythagoras or something. If you have x on the inside, thou shalt not square root a negative, because we get like an I or something. So it's okay to square root a negative when we have the directions that say solve. But this doesn't say solve, it says find domain of. Okay, so we don't want a negative under the square root. So the way we do that is we say the inside has to be bigger than or equal to 0. Because if it's bigger than 0, it's not a negative. Okay, so let's take the inside, 4x minus 8, and write bigger than or equal to 0. Then let's SAD map to get x by itself. I add 8 and you get 4x bigger than or equal to 8. Then that 4 is multiplying, so I divide by 4 and you get x bigger than or equal to 2. Okay, so if we look at our steps, this is what x can be. What x can be. So that means I can plug in a number of 2 or any number bigger than 2, and the graph will exist for this square root 4x minus 8. If I plug in, say, 1, then I'm going to get a negative in the square root, and I can't graph that. Okay, so this is what x can be. X can be a 2, a 3, a 4, a 5. So since it can be a 2, I'm going to put a bracket. And if you remember from like section 1.7, if you have the little equal underneath the gator, you use a bracket. So I'm going to say bracket 2 to infinity, because this represents everything bigger than or equal to 2. Okay, let's look at part E. It's another fraction thing, just like part C. So we're going to take the denominators, only this time we have 2 denominators. Oh no. But we're going to take both denominators, equal them to 0, get x by itself. So if I want to get x by itself on this first sucker, I opposite, so subtract 5, and you get negative 5. And then on this other sucker, I subtract 2, and you get negative 2. And these are what x can not be. We cannot have an x value of negative 5 or negative 2. Everything else within this negative infinity to positive infinity is good to go. But the trick is, my answer is not going to quite look like this part C with the 1/5, because I got more than one number that the denominator cannot be. Well, what we're going to do is, if you want to, I can draw a little number line. And I can put negative 5 on it. And negative 5 is on the left because it's more negativer. And then I can put negative 2 on it. And it's on the right because it's more negativer. And basically this problem is saying that everything up to negative 5, in between negative 5 and negative 2, and everything after it is good to go. So let's use interval notation to describe this. It's negative infinity. Roll up to that negative 5, but it cannot be negative 5, so I use a parentheses. Then the middle chunk, we can have anything from negative 5 to negative 2, but not the actual negative 5 and negative 2, so I use parentheses. And then I can have anything bigger than negative 2, so negative 2 to positive infinity with parentheses. Yay. So if you have more than one denominator, the way you make up your answer is negative infinity to the smallest of your 2 numbers, then your smallest of your 2 numbers, comma, the biggest of your 2 numbers, then the biggest of your 2 numbers, comma, infinity. But that's kind of hard to understand, so I just draw a number line. Okay, let's look at part F. We got a fraction and a house. So it's like we have to somehow combine these two. Well, In a fraction, you cannot have a 0. In a house, you can't have negatives. So with a fraction and a house, you can't have negatives, and you can't have a 0 because of the darn fraction. So how we show that you cannot have negatives and you cannot have a 0 is we say greater than. When we had a house, we could have a 0 inside. So we had that little equal to. But because we have a house and a fraction, this bottom, this x plus 6, it cannot be negative and it cannot be 0 because it comes from a fraction. So the way we say that is it has to be bigger than 0. And then we get x by itself, and that makes x bigger than negative 6. And then we write interval notation for that. The interval notation for that, let's see, it means I can be bigger than negative 6. So I can be 27. I can be 118. I can be 500. I can be 20 bagillion. So this means I can be negative 6 all the way to infinity. But this alligator does not have an equals to. As in, we can't actually get negative 6 and plug it into the denominator because it gives me a 0 and the dinosaurs die. So we have to use a parentheses. So if you have a house, just a good old house, you use a bracket. If you have a house in the bottom of a fraction, you got to use a parentheses. Okay, we're done.